Hi guys, how's it going? I hope you've been great. So today we're actually going to be looking at finding minimum element in a rotated sorted array, right? Suppose an array of length n sorted in ascending order is rotated between 1 and n times. For example, let's say you're given this array here. So it's sorted in increasing order, like from 0 to 7. So what they mean about rotated is that all the element at the end, right? Like now they are rotated, meaning they are swapped. They are at the beginning of the position, right? Like you can imagine now we had a sorted array like this. So it is rotated 4 times because we took these 4, 5, 6, 7 and we made them to be at the starting position, right? So now it's going to be like 1, 2, 3, 4. Like then that's why the answer here is 4. Okay. If you're still confused, don't worry. We're going to walk through a whiteboard and I'm going to show you how we kind of like understand these problems following a systematic approach. So another point that they're raising here is that given the sorted array, nums of unique element return the minimum element of this array. So what they're saying is that if we give you an array, what we want is you to find the minimum right element. So in this case, it's going to be 0. Okay, so you must write an algorithm that runs in O log of n, right? So I'll show you how we kind of like use a binary search technique to kind of like achieve this. Okay, cool. We have few examples, but I would like to show you more examples on the whiteboard. So let's hop to that and let me explain to you in more details. Okay guys, now that we're on whiteboard, let's follow our systematic approach towards solving a problem, okay? So the first thing that we want to do is that you want to understand the problem. So for you to understand the problem, try to write it in your own way, right? So we know that in this case, they say that given a rotated, right? A rotated array, then find a minimum right array. Okay, so you might still want to actually branch this component called rotated array if you still don't understand it. So try to write it in your own ways. Like it's fine how you kind of like write it as long as you know that you understand it, right? Because doing that way, writing it in your own way, it kind of like helps you to kind of like solidify your understanding of the problem. So in my example, my English is not good, but I'll try my best to kind of like write it the way I understand it. So in simple terms, I'll say a rotated array, essentially it means that we need to find the highest element, right, to be at the starting position of an array, right, to be at the starting position of an array. So what do I mean by this? I mean that if you're given this array here, 1, 2, 3, 4, 5, we can see that this is an array sorted in an increasing order. So if it was rotated, so what will happen is that it will then be 5, 4, then it will be 1, 2, 3. So how many times was this rotated? It was rotated 2 times, right? Like I said, the highest elements, right? Then they become the starting position. That's how I understand it in simple terms. Right? So if we are given something that did not rotate, like 1, 2, 3, 4, 5, then it was rotated 5 times, then what will happen is that we'll still get the same array, right? Because they started at 5. Like I said, we take the highest value. It started at 5, then it becomes 4, 3, 2, and 1. Okay, that's how I understand the problem. That's how like I try by all means to kind of like in this way, by doing this, I solidify my understanding of the problem. Okay, now let's look at number 2. Number 2 says, on our system approach, understand the input and the output. Okay? So, by the input, it means that what is it that we're going to insert, right? So we know that we're given, this is the input, we're given a rotated array. So a rotated array, like I said, it could be 5, 4, then we have 1, we have 2, we have 3. We know that it has been rotated 2 times, right? So what we need to do now is that we need to understand the output. What does the question want us to do then? The output says, find the minimum, right? Find the minimum in this rotated array. Find the minimum element. Okay? In this case, the minimum element is 1, right? So we need to find this. Okay? So now we understand the input and the output. Let's understand the edge cases. That's part number 3. So we have to understand the edge cases. What do I mean by edge cases? I mean all the possible scenarios that might pop up on the input, right? You might not get the input as expected. So for example, let's say the first edge case for me that comes to my mind, what if you are given an empty array? How are you going to handle that, right? What if the array has only one element, right? So how are you going to handle that, right? So the another one is that what if all the elements are the same, meaning like there is 1, 2, 3. So although we did this example, we know this is sorted 3 times, but these are the type of things that you should take into consideration. Okay, right? Step number 4. So I feel like some of you might feel like I'm wasting time because I have not solved the problem yet. And the truth is, what I'm teaching now is that like we should always have a systematic approach. Not all the time, whenever you're given a problem, you will be able to know the solution right away. So, but having something like a systematic approach, then you can work your way through towards the solution, right? Like understanding it, trying to come up with the SQL solution and coming up with a brute solution, then you might find yourself actually coming up with the solution and optimizing it. Okay, so step 4, what we want to do now is that we want to come up with a brute force solution. This is not an efficient solution, but it's just to say, let's put ourselves in the shoes whereby we didn't actually know how we're going to solve the problem, right? So we're just coming up with the brute force solution at this point. So to come up with the brute force solution, we're just like writing the solution in our own words. It's not going to be efficient, but it will solve the problem, right? So the first thing that I'm thinking of doing is that, okay, let's imagine that we're actually given, let's say 4, 5, then we have 1, 2, we have 3, right? Let's say we're given this rotated array. We know it's rotated 2 times. Then how can we then find the minimum value, which is 1? Okay, for me personally, I'll say, okay, how about we loop through, right? How about we loop through the elements, right? So we loop through the elements. Then what happens is that we check, that means we're going to write an if-else statement, check if the first element, not the first element, rather the element that we are currently looping through, let's say it was 4, like we check if it's 4 greater than or less than the last element, right? The last element here, I'm just talking about 3, right? So we check if 4 is greater than 3. Why are we doing this? It is because we know that actually if we try to understand the last element, 3 in this case, it's actually going to help us to understand if the element was rotated or not, right? In this case, if 4 is greater than 3, we know that actually it was rotated, right? Because the small element is at the end and the large element is at the beginning. So we must move to the right. We must continue with our process. Okay. Then we're going to continue checking that. As we move on, then when we get to 1, we will find the answer because this condition won't pass anymore, right? It won't pass. It will try to say, is 1 greater than 3, which is false, right? So when it's false, we know that we have actually found our minimum element, right? We found our minimum value. So what does this mean in SOTE? So we can have 3 scenarios. So let's say this one was not sorted, like 2, 3. So how will we handle this? Same thing. We're just going to use this check here to check if the first element 1, is it greater than 3? No. Then we found our minimum. That means here, this is our minimum, right? We found our minimum. Okay. So that's how I kind of like think of like how we can go about this, right? Brute force solution is going to work and it should do the job. But I'm not going to write this. I'm just showing you how you kind of like work your way through towards finding the possible solution, right? So obviously we saw that they said that we should come up with a solution that is going to give us the runtime of O log of n, right? So here in terms of the complexity, we know that this solution is going to give us O of n because we have to go through each element, have to loop through and check and stuff like that. In the worst case scenario, we can imagine that whereby the array was actually sorted n length of an array, so it's gonna be like way too it's not gonna be too efficient in a way. Okay, so what we want to do then is that we want to come up with an optimized solution, right? We can use a binary search technique, right? So I explain a binary search technique. Please check my previous videos if you are still confused about this technique, but this is a technique that we're going to use. Okay, so let's jump to the code, and now we can start writing the code, and we're gonna end by analyzing the complexity. So we have 6 steps in this case, the complexity of the optimized solution. Okay, so let's jump to the code. Okay guys, now let's code our solution, right? But before we do, I just want to say the reason I created the brute force solution was because you can imagine that there's going to be a point whereby you don't know the solution of the problem, right? So the brute force solution is just a way to kind of like work your way through a solution, although it's not going to be efficient, but it solves the problems, right? Then what you do from there is that you work your way up, like you trying to like optimize it, and right. So that was the goal of like kind of like teaching you how kind of like you come up with the systematic approach. It kind of like helps because that shows how you can like solve the problem. Okay. In this case, I'm not gonna code the brute force solution. I'm just gonna go straight to the optimized solution. Okay, guys. So, like I said, I'm going to use a binary search to achieve this. So what you want to do in this case is that you want to get your low index, which is 0, and you want to get your high index, which is going to be the length of the nums of the array. Then you just minus by 1. Okay. Then what you do, then you just say while you still remember all the edge cases that I told you about, whereby then array can be empty. So this code here just also help us to kind of like handle that, right? So low less than or equals to high. Then what you want to do is that you want to get your mid number. To get your mid, you're just gonna say low plus high, then you divide by 2. So that sign there is just to say don't give me the decimals, right? I want an integer. So you just get your mid number, which is equals to you're just gonna say nums, then you're just gonna say mid. Okay, so this is very important. What I'm going to write here is quite very important. So the first thing that we want to do is to handle a situation whereby we have only single value in an array, because the subsequent code that we're going to write essentially is going to assume that there is no single value. Like there's something behind an element, right? There's something behind a mid number, meaning there's a value behind each value, like if I'm making sense, right? So what we want to do then is to handle a situation whereby we have one value. So this is quite simple. So we just say if length of nums, right, equals to 1, so we can just return that value, like that's the rotated value anyway. So we can just say nums then low index, right? Then now what I want to do is to write a code whereby we're returning the minimum value, right? So you can imagine that for us to get a minimum value is that you can there's always going to be a greater value behind it all the time, right? So if like this was the minimum, if 0 is the minimum value, and we can imagine that now it's our mid value, so what we want to do is that we want to check behind it. So in this case it's 7, right? And 7 is greater than this 0, right? So that will always be the situation. So what you want to do in this case is that you want to say if mid number, right? So what's behind it? So if what's behind it, like if it's greater, just say less. Yeah, it's fine. So we just want to say nums. Here I'm just gonna say mid, because what's behind the mid number? Then we say -1, right? So we say take the mid number, but we're gonna say -1 because we want what's behind it. Like if I'm making sense, guys. Okay. Actually, this was supposed to be inside, because we indexing, right? Yep, because we're indexing. Okay, cool. Now we're just gonna say return the mid number. Okay, so now let's think of a case whereby we have a lot of numbers, right? So we have, this is our mid number. Think of this case whereby this is our mid number. So what we want to do in this case, you still remember in our brute force solution, we used to check the highest value, like the last value of an array. So we're just going to use the same technique, because that actually helps us to understand if this was rotated or not. Okay, so what we want to do in this case is that we want to say if the mid number, so if the mid number is less than the last value, like I just said, so you're just going to say nums. To get the last value, you just have to say -1, and you just have to say and, because you have to check if the mid number is greater than the value behind. Like I said, in this case, if the mid value was 1, you want to check if it's greater than 1, it's greater than 0, right? So in this case, it is. So that means you have to go to the left. So what you want to do in this case, you just want to say mid number greater than, then we're just gonna say nums, you know, like as always, nums mid, then you just say -1, right? So you get just your mid number and subtract it by 1. Let me think. Okay, I don't think we have any mistake here so far. Okay, cool. What we want to do is that we want to update our high, because now we know that we want to go to the left, right? So what we want to do is that we want to update our high. So we're just going to say high equals to mid. So it's going to be mid -1. Okay. Okay, now what we want to do, guys, is that we want to compare a situation whereby our mid is actually greater than the last element, right? So what we want to do is that we're going to say mid number, right? So it's greater than the last element. So we're just going to say nums, okay? Then we say -1, and we're going to put an and there. So what we want to do, like I said, imagine if this 5 is our mid number. So you want to check if it's greater than 4, right? So you want to say, because we want to go above, we want to go like to the top, right? So that's what we're going to do. We're just going to say mid number. So we're just going to check if it's greater than mid number greater than nums mid minus 1. So that's what we're doing here. Just saying if 5 is our mid number and is greater than 4, because now if that's the case, then we know that then we have to go up, because when we go up, we're going to find our minimum value. Okay, so now that means we're going to have to update the low index. So we're just going to say mid plus 1, and then the last element is going to be else. Just return -1, and outside of for loop return -1. Right, I don't know if I made a mistake, guys, but that's how I kind of like think this is the solution. So let's submit and check it out. Perfect, guys. So the solution was actually accepted and is actually fast, right? So that's all, guys, I have for you guys. So hopefully I will see you in the next video. Thank you guys for joining me.